This is the cable. Let's look at the wiring at the rear. Positive and negative extremes. Red connect positive, black ones connect negative terminal. These two lines in the middle are the voltage acquisition lines. It's also red plus and black minus. Now we turn it on. Boot into our main screen, and then hit Set. The password is 13982. Enter Settings screen. Then click Discharge Test. Template is Test Template. Here are some basic parameter setting. The whole group voltages. Set based on your actual condition. That's how many volts is your battery pack at site. Pick the corresponding. You can choose from any of these. This is group voltage types. Here is the individual cell module voltage, 1.2 V, 2 volts, 4 volts, 12 volts. This is to set a time interval of data recording. This is a switch between external sensor and internal sensor. Usually we just set internal as default. Capacity setting is also based on your battery pack. Maximum discharge current. Maximum discharge current should be set higher than the max current value of your instrument. This device max value is 250 A. As it is a protective use, so it can't be set as exactly the same value. For example, if you want to discharge 100 amps in your test, if you only set this up for 100 amps, then probably at about 100 amps, it will report a malfunction. So set a little higher than the target current you need to set. About 10 amps higher. After you set these parameters, we hit OK. Here also have some parameters setting. Here is a capacity setting. This capacity setting is what you need to discharge on site. Let's say your capacity is 1000 R, but you might actually only discharge 800 or 900. And then you just set 800 or 900. This is a discharge time duration. We are discharging at 10 hours. This is the low limit of a single segment cell. If your cell battery is 12 V, so its low limit is 10.8. This is the low limit of the whole battery pack. The low limit of whole pack is based on your battery. For example, low limit of 110 battery pack is 88. Then this is discharge current, an initial discharge current. We set 10 A. The low limit for the whole pack is the pack voltage multiplied by 0.8. This value. This low limit is to protect the battery from excessive discharge and damage the battery. It has a protective effect. When you discharge, be careful below note. This captures the present voltage. After the present voltage value is stable, and then we close this L switch down here. Close this L switch. Then click Start Discharge to discharge to 10 A. When the discharge starts, same situation. When we see the present current and voltage is stable, and then we add the discharge current value little by little. Now we add to 50 A. We are using a simulated load. Its voltage keeps the same, the current will change. You have a real battery load on site, and both current and voltage will continue to drop. When the current stabilizes, and then we can add more. We add more. 100 A. This is our simulated load. Let it stabilize first. Add current to 150. 150. Add current to 180. Voltage of our stimulated load is basically stable. Its current is rising because ours is a simulated load. Add to 200A. Where does this discharge current go? When the battery is connected to a discharger, the discharger converts the battery's electrical energy into heat energy. So the side of the battery discharge tester is hot and it has many fans for ventilation. This heat on the side is normal, but also pay attention to ventilation and cooling. Now our experiment is almost complete. This is the data of cell monitoring. This is the voltage of the cells. Customer needs to purchase single cell monitoring module. For example, the customer has 5 modules. Here we show 5 groups of data, each of which is 12 cells, a total of 60 cells. 1, 2, 3, 4, 5. And when we are in the discharge process, we can monitor in real time. Monitor the voltage change of each battery cell. This USB port, you can plug your disk to export data to generate reports. Small tip 1. Use of alarm. There's an alarm. Now let's try the usage of alarm. Then we stop now. Click OK. Let's turn off the air switch. Then we click Start. Wait, the current is 200 now, so let's set the current to 10. Then click Start. Then click OK. It will alarm. Because you didn't close the circuit breaker, it didn't form a loop. So here will alarm. And here reports a malfunction of break off. So when you want to discharge, you have to close the air switch. Now click Restart, and then click OK. And then if your set capacity or duration is reached, after one of these conditions is met, it will alarm to remind you the capacity or the time is complete. The alarm sound is to alert you to check it out. In short, the alarm plays a warning role. Tip 2. How to operate when the discharge is suspended. It is now in a pause state. That means it can't go back. Click ESC. It asks you to wait for test to stop. Need to click Stop. When you hit Stop, here will show Data Saving. Wait until there is no data saving hint. Then you can click Return. Tip 3. Constant current and constant power consumption. We basically choose constant current. And then this down here is constant power. Basically, customers really use constant power. Finally, let me show you each function. This is a parameter of the whole machine. Help Center. More detailed help documentation is available in our paper and electronic documentation manuals. This is a quick test. You don't usually get to use that. This is an online monitor. This is the stored data. We can export this data, generate a report on our computer software. That's a curve. the voltage and current in the working state. System setting. This is the Chinese and English language switch. Try switching to Chinese. Switch language here. Now it's English again.
Thank you for watching the tutorial video prepared by Hipot Tester.